Hello, everyone. This is Dr. Song. I'd like to start our video about the quantitative research method in the YouTube video. So, thank you so much for your visiting my channel. And in fact, when I started this course online, I was thinking that how I can share what I understood from the quantitative research method as a student. So I learned this course when I was in the university. I was still a student, and then that was from the undergraduate level. And then also I continued to study this course, when I was in the master and the doctoral degree also. So I think it's very important to study this course. It's not only to pass your course, but also how you will have the knowledge about the quantitative research and related software, because this can be your competence when you finish your studying and then you go to your work and your boss will ask you what is the important thing you learned from the university. You can say many things. Of course, you learned many things, but if you say that you have competence about using SPSS and also to run the quantitative research, I think that will be the really the bonus point. So don't think they are only the past course in your university courses, but also think about the more long term. When you have the really the basic knowledge about quantitative research, and that will be the really the your benefit, and then you can maybe have the better promotion also if you are working already. So that is I wanted to tell you. Okay, so I got the content and then textual images from these three courses. So they are my professors. They were my professors, and I learned a lot from them. So these are the resources. So today I want to talk about what is JET scores. So according to my understanding, JET scores, that is individual scores, how they are distributed on the data. So JET scores are related very, very closely to the standard deviation. So if you remember well, the standard deviation has this is the your data and how it's distributed, and from the zero they have the zone of the one and the two and the three. So that is your standard deviation, and then from the zero to the left part, right part, totally about the 67 or 68%. That is the zone of the standard deviation one. 95% from the left and the right side, that is a standard deviation zone 2. And then from the 3, left to 3 and then right to 3, that is a 99% of the standard deviation 3. So that score means that between the -3 and then the +3, how individual scores are distributed in this line. So that is the jet scores. So that's why that is very much related to the standard deviation. And also, you will find what is a percentile. So you know that the score that is converted in the jet score, the individual score converted in the jet score, you will, when you see this jet score, you can convert to the percentage, and then you will have a better understanding from where that your individual score is situated. So when it's at 1.96, that is the jet score 1.96, that means it's 97.5%. That the location, the position of the score in your data is 97.5%. So that means that. So three things very important before starting the jet scores. Jet score is a very related, is closely related to standard deviation, and also that indicates that the position of the individual score in your data, so that can be expressed only by also by the percentage. So this is what I really understood from the Z-score. Individual score fall in the data. Yeah, what I said. How far from the mean? The mean is here, the 0. So how far they are from the mean, the score, and then if there is more than the plus minus 3, that is extreme scores, and we call that outliers. So that means that, and then we can also find the what percentile, yeah, exactly, how much percent the position of the test score we can see. So if the test score fall inside of the 68% area, that is the standard deviation 1, zone 1, and then that is 84, that 84%, that is a second zone 2 is a before, because 84% is that is 84%, yeah, so that is a standard deviation 1, yeah, so that is a 1, and then if more than 1, and then you can say that is over 85%. This is 97.5%. So it can be the between two, that is a zone 2, standard deviation 2. So that is the explanation. 68% points within the one standard deviation, and then 95% from the two standard deviation, and then that is 98, 99, 99% that is standard deviation 3. Okay. And then to score, how you obtain that, the individual score minus the mean average, and then you divide by standard deviation. So you can obtain the Z-score by this simple calculation. So you can see that the individual score, you put that, and then minus the mean score, and then divide by the standard deviation. This is the formula how you obtain the Z-score. Normally, you can obtain the Z-score very, very easily through the SPSS. So I already explained to you, but when you go to, this is the one data, and then let's see what is the individual score as a jet score converted to jet score. So we will do this time the burnout. So you go to the analyze, and then descriptive, and then descriptive. And then you can put the burnout here in the box, and then you can check the save the standardized value. That means the jet score. So you can check that, and then okay. And then you will see that there is generated the one another variable in your data. So you can see that here in the end of your data is a jet burnout. So these are the individual scores are converted as a jet scores. So you see that is a plus 1.49. So that means that it's not yet 1.96. So that means that, yeah, let's see the which one was. So the yeah, so that is 1. 1 means the 84%, and then that means the zone 1 of the standard deviation. But yours is a greater than 1, but not yet 1.96. So that is a zone 2, standard deviation zone 2, that score. So you can imagine in your mind how that is situated. And then this is a minus part. So that is also the greater than 1. So that is also zone 2, standard deviation zone 2, etc. So you can get the whole set scores of each individual score. It's very easy to find that by the SPSS. So when you see this one, for instance, 3.7, that means that is greater than 99%, and then greater than standard deviation zone 3. So this is an outlier. So you can consider that. So you see, it's very easy to detect the outliers and the data scores of your individual score by just a simple click, analyze, and descriptive, and then descriptive, and then just that one. So that is very, very useful. Okay. So that I wanted to explain. And then this is what I showed you. So the zone 1, that is the between 15.9 to the 84. Yeah, so that is the zone 1. And then 97.5 and then 2.5, that is the 95% the zone is a standard deviation 2. And then 99.5, that is a standard deviation 3, the right part. And then the left part, that is 0.5. So you can see that here, 2.5 plus 97.5, that becomes 100. So already that will work with the together, left part and the right part. So one score, let's say that is a Z-score 1.96. That means that is situated in exactly the point of the 97.5%. And then one score that is situated in the minus 1.96. That means that that is the position of the 2.5%. So you can see that that is increasing to the right part. And then you will see that there is a minus part that will just be calculated as the minus is a small number of a percentage. And then when it's going to the extremely right side, that will be until the 100. So this is the how you understand about the Z-scores. Yeah, so this is just what I explained until now. That is more like the summary of the Z-score thing. So how you know the Z-scores easily? You have the table. But let's say the first the formula. So 85 is individual score minus that is average, and then divided by standard deviation becomes 1.5. So 1.5 means there is a greater than standard deviation zone 1. And then you can see here 50, that is just average, plus 0.4332, that becomes the 0.9332. That means that 93.32% is the score is situated. Okay, so that means that is a minus, that is a left side, and then you can say the 50 minus this number. So that is about the 34% that is situated like this. So this is the how you obtain the Z-score. So you can see there is a 2.5%, 2.5%, that is a 95% zone. And then this is this means that 97.8%, this is 2.5%. This is 97.5%. Okay. And then what is this means? That means that when you consider this a one tail, this is two tails, this tail and then this tail. But if you consider only the one tail, and then you can consider there is only the 5%, yeah, and then the other is the 5%. It can happen. So that is according to your hypothesis. If you say that is I don't care about the minus or plus, but they have the two tails and then correlation. For instance, you can say that is a 95 enough 95%. There is 2.5 left and then 2.5 right. Anyway, they are correlated, negative or positive, and then you can consider that is your p-value. And then if you consider there is only one tail, that is like that is only the negative part. And then you can say that only 5% from for the negative part, not the positive part. So that is really related to hypothesis. We can see that when we will have the session about the inferential statistics. Yeah, so again, that is a normal distribution, and then that is standardized, and this is a standard deviation. You can see that how they are standardized, and this is the Z scores. Yeah, so the Z table, that is something like that. Yeah, something like this. So when you go to the Z table, and then they are written in the like a percentage. When you do a multiply by 100, that becomes the percentage. So when you know the your Z score, you will know also how they are situated. So this is about the Z score tables. Yeah, and then this is also again about showing the only the one tail. Yeah, so the one tail only. And then this is 1 plus minus 1.96. That is about the standard deviation 2 zone. And then something is less than that. That is the something observed is less than jet critique. That is 1.96 is 95%. Generally, we consider p-value with the 1.96 plus minus. Okay. So this is about the Z scores. I think I just explained that what is most important. But of course, we will deal with this in the following sessions. Thank you so much for today. And then I hope I can explain more next time. See you next time.